Okay, we're going to start off this section with an example. So the question asks us, use the definition of a derivative to find the derivative of f of x equals x cubed plus x at x equals a. Okay, so we're going to start off with, we want to find f prime of x, so that's just saying we want to find the derivative. And we're going to use our definition, so we're going to limit as h approaches 0 of f. We're going to substitute 0 in for x, so it's going to be 0 plus h minus f at 0 all over h, okay? And the next stage, I'm going to say that's the limit as h approaches 0. As I plug 0 plus h in, I'm really just plugging h in, so that's going to be h cubed plus h minus 0 plus 0. So it's just minus 0 over h. So that's going to give us the limit as h approaches 0. I'm going to factor out an h out of the top, so that's going to leave me with h squared plus 1, h squared plus 1 over h. Then the h's cancel, and I'm left with a limit as h approaches 0 of h squared plus 1. And when I substitute it 0 in, I get 1. So that means the slope at the tangent line at 0 is 1. Okay, we also need to talk about an alternative definition, but the reason why this is alternative is basically we're going to change and relabel our picture. And when we relabel our picture, we'll get a new definition, but it's the exact same idea we've been working with. Okay, let's say we want to find the slope of a curve on a coordinate plane here, and we've got a point here and a point here. We still want our change in our y over our change in x. The difference is that we're going to label this value a, and instead of a plus h, we're going to let it be x. So over here, this is going to be f at a, and this up here is going to be f at x. So we still want to find the change in our y over our change in our x. So when we go to find our change in our y over our change in our x, instead we're going to subtract f at x minus f at a, and it's going to be over x minus a, okay? And in this case, we need to think about the definition. So what are we going to let our limit be? Well, the limit is going to be that we want x to approach a, okay? Because we want that x and a to get closer and closer. So that's going to be a limit of f of x minus f at a over x minus a. Okay, so now we're going to try an example where we apply the alternative definition to find, we've already done this problem previously, but we're going to look at f of x equals 1 over x, and we want to see what the derivative is at a equals 2. So we're going to use the alternative definition, so we're going to let x approach a of f of x minus f at a all over x minus a, okay? So because a is 2, I'm going to basically plug a is 2 into here. So I'm going to look at the limit as x approaches 2. Okay, now when you substitute in, you're going to be looking at f at x minus f at 2 all over x minus 2. Okay, so now I'm going to substitute that in. So I'm going to get the limit as x approaches 2 of 1 over x minus 1 over 2 over x minus 2. Okay, now I need to get a common denominator of 2x. So that's going to leave me with a numerator of 2 minus x. Okay, just really quickly to show you what happened here. When I go to get my common denominator of 1 over x, I got a denominator of x. I added a 2 to the denominator for this fraction, so the 2's would cancel, and that'll leave it as 1 over x. Over here, if the x cancels, it's going to leave it as minus 1/2. Okay, and that's going to be all over x minus 2. So that's really going to be over 1. So that's going to work out to be the limit as x approaches 2 of 2 minus x over 2x times, I'm going to flip this and make it 1 over x minus 2. Okay, nothing really cancels here, but we do notice that, let me highlight it for you here. We do notice that 2 minus x and x minus 2 are opposites of each other. So if things are opposites of each other, this can cancel, but it's going to be a ratio of negative 1. So then I'm going to get the limit as x approaches 2 of negative 1 over 2 times x. All right, so now I can substitute, and so that's going to be negative 1 over 2 times 2, which comes out to be negative 1/4. And that was the same answer that we got earlier with the alternative, with the initial definition.